Welcome to geometry class. In this video we're going to start section 15-1 that covers central angles and inscribed angles. Here in the warm-up it says draw a circle, so there's my circle. And it says label and draw the following, the center. Well, right at the middle of it there, I just label that C for center. I'll use blue for the radius. The radius of a circle goes from the center straight to a point on the circle. So I will do R for radius, and then I'm going to switch to black ink for the diameter. Diameters go across the whole circle, and they go through the center. So the black ink, I'll use letter D for diameter. And those are terms you should have known from a previous math class. Here is some fill in the blank. I'm going to go through these kind of quick. You can always pause the video to catch up. Investigate central angles and inscribed angles. A circle is a set of all points in a plane that are equidistant from a given point called the center. A chord is a segment whose endpoints lie on the circle. I'm going to draw a real quick circle here. So if I draw 2 points, like here's A and here's B, connect them, that is a chord. A diameter is a special chord that cuts through the center of the circle. So again, if here's my center, if I draw a chord going across the circle that happens to go through the center, that's called the diameter. A central angle of a circle is an angle whose vertex is at the center of the circle. Central angle, vertex at the center. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So if I do another quick circle here, let's say I'm going to put my vertex, I'll call it V for vertex, and then I got point A over here and point B over here. So if I connect V to A, that would keep going through, but V to A is a chord in the circle. And same thing for VB. VB is a ray, but this VB is also a chord in the circle. So remember, a central angle has its vertex at the center of the circle. An inscribed angle has its vertex somewhere else on the edge of that circle. And here in example 1, we did have a little typo. Draw the following vocab words on each circle. Label the intersection points. So the first one's good, chord. I'm just going to put, I'll use red ink. I'm going to put point A here. I'm going to put point B here, and I'm going to connect them. So segment AB is a chord. Now for the central, notice I did, down here it says central, and up here it had inscribed, so I changed that to central. I'm going to put point A and B roughly in the same spots. And if I connect C to A and C to B, I could write angle ACB. Angle ACB is a central angle. Its center vertex is at the center of the circle. I'm going to switch to blue ink. I'm going to put A and B in roughly the same spot. Over here, I'm going to call this point D, and I'm going to connect D to point A and D to point B, and this would be an inscribed angle. Angle ADB is inscribed, and again, for any of these angles, I could write them in reverse order as long as the vertex is in the middle. So there's our central angle at the center of the circle. Our inscribed has its vertex on the circle. Now here, this is a practice problem. It says team huddle, so if you could pause the video and then start it back up after you've answered these and see how well you do. Okay, let's see for the one on the left here, chord. So I'm just going to use chord. Let's see, we've got this one I'll highlight in red. AE is a chord. Here in blue, AB is also a chord. And I think that's it for that circle. Inscribed angle. I'm going to abbreviate inscribed angle. So here, the two sides I have in red and blue mark out an inscribed angle. We could call it angle EAB or angle BAE. But that's the only vertex I see on the edge of the circle. The last one here, central angle, central angle. And what do we got here? The obvious one here is BCD, angle BCD. We could do A to C to D, angle ACD. And we could also do, let me erase on my picture, ACB would also be, ACB is also a central angle. Angle, or C is the center of all of those angles. All right, on to part B, our chords. Let's see, we've got AD. I'll highlight that one in red. In blue, we've got AB. And I think that's it for chords. Inscribed angle. Once again, the red and blue lines do make up an inscribed angle. That would be angle DAB or angle BAD. And that's it for inscribed. That's the only one with a vertex on the edge of the circle. Our last one will be the central angles. Central angle. So I'm going to look right here and mark this one with a blue arc. That would be angle ACB. I'll mark this one here with a red arc. That would be DCA. And then over here I'll use black ink, DCB. And again, all of those could be written in reverse order as long as C is in the middle to represent the vertex. Okay, some more fill in the blank. Understanding arcs and arc measures. What's an arc? An arc is an unbroken part of a circle consisting of 2 points on the circle, called the endpoints of the arc. So it includes the endpoints and all points in between. If we look real quick over here at the picture, here's point A, here is point B. Arc AB is all the points, including the endpoints and everything that in between them. And notice we got this little arc thing here over top. You know AB, this would be the segment AB. Now this is the arc AB. And let's go fill in some more blanks here. A minor arc is an arc of a circle whose points are on or in the interior of a central angle. And how do we measure it? The measure of a minor arc is exactly the same as the measure of its central angle. So the arc and the central angle have the same measure. We could write this. The measure of arc AB is equal to the measure of angle ACB. ACB. If we look over here on the picture, here is the measure of angle ACB. This is going to be some amount of degrees. Let's just call it 80 degrees. If this central angle is 80 degrees, then arc AB is also 80 degrees. The measure of the arc and the measure of the central angle are exactly the same. So we had a minor arc. Now here's a major arc. A major arc is an arc of a circle whose points are on or in the exterior of that same central angle. If we look back over here, we saw the central angle ACB. Well, we got a point D out here. That means if we start at A, we got to go to D first before we can continue on to B. So the measure of a major arc is equal to 360, that's a full circle, minus the measure of the central angle. So here we could fill this in. The measure of arc ADB is equal to 360 minus the measure of angle ACB. Oop, that's supposed to be a B. B. So we find this angle, whatever it is, call it a question mark. We would subtract that from 360, and that would give us the arc that goes around the rest of the circle. Okay, now in the last one here, a semicircle is an arc of a circle whose points lie on the diameter. So the measure of a semicircle, half a circle, is 180 degrees. And if we look at our picture here, we're going to start at A, and we're going to go to D, and then to B. So the measure of arc ADB is also equal to 180 degrees. Okay, let's put some of this knowledge to use here. Let's read our setup. RV and QT are diameters of circle P. So here's the center of circle P, and we have RV and QT. Tell whether each arc is minor, major, or a semicircle, and then find the measure of it. So let's see here. The first thing, let's look at this circle. Let's fill in all our blank spaces. Here is a diameter, so that's half a circle. That's 180 degrees. And we've got 43 here and 52 here. So if we want to find arc RS, and I guess that's right here. Let's fill this in. RS. RS is a minor arc. Minor. And it's going to equal 180 minus 43 minus 52. So if we subtract those out, we get this is 85 degrees. Okay, look at TV here. TV we're not asked for, but it is vertical with the angle over here. So this angle RPQ is 43. TPV will also be 43. And this might be enough to answer all these questions. So here it says, what's the measure of QR? Well, I'm going to use red. Here's QR in red. It comes from a central angle of 43 degrees. So the measure of QR, it is a minor arc. It is also 43 degrees. We already found RS. RS is also a minor arc, 180 minus the other two angles. That's our 85 degrees. Now let's see here, QST. So we're going to go from Q, we're going to go to S, and then we're going to go to T, and look at that. QST, that is half a circle, and I know that that is a semicircle, and that's 180 degrees. Last one, Q to T to V. So here's Q, and we're going to go to T. So that's 180 degrees, and then we're going to go a little farther to V. So this, to find the angle, is, or the measure of the arc, is 180 plus the extra 43 degrees here. So that adds up to 223, and that is also a major arc. Okay, that's example 2. Number 3, we got a clock. The minute hand of a circular clock sweeps out in an arc as it moves from 9:10 to 9:25. So here is 9:10. Our second hand was on, or the minute hand was on the 2, and then at 25, the minute hand is on the 5. So it says, what fraction of a complete rotation did the minute hand travel? Well, a complete rotation would be 12 hours. And we went from 2 to 5. So we went 3 of those units. 3 over 12 reduces to 1/4. There's our fraction. Part B, a complete rotation of the minute hand is a full 360 degrees. What is the degree measure that the minute hand traveled? What angle does this represent? Well, we know it traveled 1/4 from part A, and we just want to find 1/4 of 360. So 360 divided by 4 is 90 degrees. What angle did this measure represent? Well, that would be the central angle. So we went, I'll use red ink. We went from the center of the clock to the 2, the center of the clock to the 5. So this arc out here is 90 degrees. That means our central angle is also 90 degrees. What is the measure? Oh, I guess I kind of already answered this. What is the measure of the arc formed on the clock? So that is our 90 degrees. The arc is equal to the central angle. So if we had a 90-degree arc, it leads to a 90-degree central angle, and vice versa. Our last little vocab thing here. Adjacent arcs are of the same circle and have a common end point. Like if this is the edge of a circle, and this is A, and this is B, and this is C, arc AB and arc BC are adjacent. They share the end point B. So much like we had segment addition, we could have arc addition. Okay, I think this is our last example, then the rest of the practice. Example 4, find the value of x and then find the measure of the central angle BAC. So here, they gave us the angle inside here. Angle A is 7x minus 7 degrees. And the length of this blue arc from C to B is 6x plus 13 degrees. Well, that's a central angle and an arc out there, so they have the same measure. We can set 7x minus 7 equal to 6x plus 13. And we want to solve and get x alone. We can do it in 2 steps. We're going to subtract 6x from each side. And we're going to add 7 to each side. So 7x minus 6x is 1x. 1x equals 13 plus 7 is 20. So that's the part here. Find the value of x. Now it says find the measure of central angle BAC. Well, we're just going to plug this 20 either in for this x or this one. Doesn't matter. I'm going to plug it into the 7 times x minus 7. And we're just going to put a 20 in there. So that's 140 minus 7. 140 minus 7 is 133 degrees. All right. Last example. So again, some practice problems 2 through 6. Pause the video. Try the practice problems. Fire it up and see how you did. All right, let's see what we got here. Let's start with the minor arc on this one on the left. I see a bunch of them. AD, DE, that's supposed to be an E. EB would be minor. BF would be minor. AF, yeah, and that'd be all of them. Now, major arc, let's see here. We could do ADF, going all the way around like that. ADF. We could do DBA. DBA. There's going to be a bunch of these. You know, they're going to be named with 3 letters and do more than half a circle. Like if I pick out BF, I would just do anything around, like F to A to B, or I could call it F to D to B. If I wanted to use this as my minor, then my major arc would be D to A to E, or I could call it D to F to E, any of those. Again, there's going to be a bunch of these. If I called, no, I already did that one. BF. So FDB or FEB. Again, there's going to be a bunch, as long as it's 3 letters. And if you pick out, like I said, here would be your minor arc. The major arc would be everything else around it. The last one here, semicircle. So this looks like a diameter. So we could do ADB. We could do AFB. And then we got another diameter here. So we could do DEF or DBF or DAF, something like that. I think that's it for the left triangle or circle. Now over here, part B. Let's do the minor arc first. So minor arc, you could do DB, or you could do AB or BA. Either of those would be fine. Major arc. Again, if I did this as my minor, then my major would be DAB to go all the way around that way. If I chose this as my minor arc, then my major would be A to D to B. Those are good. As a semicircle, again, here's our diameter. So our semicircle would be DBA. D to B to A. All right, find the value of x. We have a central angle of 74. We have this arc of 7x minus 3. Central angle is equal to its arc. So 7x minus 3 equals 74. Let's add 3 to both sides. 7x equals 77. Let's divide by 7. X is 11. Find the major, minor arcs and semicircles. Let's go over to our picture. Let's find our missing stuff. So let's see, here is half a circle. So that's going to be 180 degrees. And we'll do 180 minus 70 minus 45. And that's going to be 65 degrees. Let me write that in here, 65. Notice BFC is 70, and vertical to that is AFE. So this is also 70 degrees. And I don't know if we need this arc AB, but it's a semicircle here. That's 180 degrees, and we've used up 70 here. So this is 110. All right, let's see what they're asking us. DC. DC is here. That is a minor arc. And we already figured out it's 65 degrees. Okay, B, A to D. So here is A, and we're going to go to D. We found these two chunks, the 70 and the 45. They're going to add up to 115. And that is also a minor arc. Okay, next, E, DB. So we're going to start here, E, and go to D, and then keep going on to B. Oh, that's an easy one. That's a semicircle, and that's 180 degrees. Last one, B to D to A. So here I am at B, and I'm going to go to D, and I'm going to keep going to A. So all the way around. We could add up the 70, the 65, the 45, and the 70. Or if we notice this is a semicircle, that's 180 degrees. 180 degrees plus this 70 degree more. 180 plus 70 is 250 degrees. And we have a major arc. All right, up next, the clock problem. The minute hand of a circular clock sweeps out at an arc from 235 to 255. So here's the 35, and I'm going to put the 55 on the same clock here. What is the measure of that arc? So let's see, if we're here at 7, we've gone 1 hour, 2 hour, 3 hour, 4 hour. So we've gone 4 out of 12ths out of the way around. 4/12 reduces to a third. A full circle is 360, and 1/3 of 360, 360 divided by 3, is 120 degrees. So what is the measure of the arc? 120. All right, last one. What are the measures of JK? So here's JK, KL, KL, LM, LM, MN, MN, and finally NJ. So they're asking for each of those arcs. Keyword here is it's a regular pentagon. Regular meaning all angles are the same. So all the angles inside will be the same. We've got 1, 2, 3, 4, 5 of them. So this is easy as taking the full 360 and dividing it into 5 equal slices. Each slice will be 72 degrees. So that 72 is for all of these different arcs. All right, that's the end of the practice. That's the end of the video. I hope it was helpful, and I'll see you for Circles Day 2.